Everyone, in this video I'm going to go over exam number 14 tutorial. I actually wanted to make this tutorial on Friday. I was actually making this tutorial on Friday at broken time, but while I was making the video, I got a phone call from my wife. My son got accepted at Ivy League Brown University.
Me?
No, wrong son, not you, baby. You are Stony Brook one.
Oh,
the other
shucks.
one. The other
Me?
one. my son got accepted at Brown University. It's an Ivy League University. Congratulations. All right. Okay. Very good. Now go. I have to make the video. Okay. The first problem is 25 kilogram object, right? A box which is moving from location A to location B, which is about 2 meters. And the surface is, let's say, mu s is 0.5 and mu k is 0.4, and someone is pull the box with 123. Fa is 123 newton. Okay, so what I want you to ask, the work done by that force. Okay, so let's see how we can solve this problem, and maybe we can start with free body diagram. 25 kilogram, or maybe we don't have to write 25 kilogram here. We're just gonna draw the box, this box, and this is 25 times 9.8, which is 240, which is 245 newton, right? And this is the weight of the box, right? And this is normal force would also be 245 newton. Excellent. Now what are you going to do? You're going to try to find the friction, right? And this is the friction. But who is friction? What is the friction? How can we find the friction? Okay, the friction is FF S max FFK, right? This is mu s Fn, and this is mu k Fn. Mu s Fn is 0.5 times, of course, the normal force, which is 245. This is 1 to 2.5, right? And this is 0.3 times 245, and this is, of course, 98 newton. Now look, 122.5 is smaller than 123. What does that mean? S max is smaller than Fa. If that is the case, then of course FFK. All right, so now we know why this is going to be 98 newton. Excellent. And this is applied force, of course. Applied force is 123 newton. Good. Now you know the net force. We can erase it. I think I need a napkin or eraser, but anyway, we can find the net force. What is net force? Net force is F is equal to F. Okay, so what is net force? What is all the forces acting in the x direction? Let's see, 123, or maybe Fa minus FFK is equal to net force, right? So 123 minus 98 is equal to net force. So net force is 25 newton. Okay, now work done by net force is equal to F net d, which is displacement, of course. Don't forget that, cosine theta. Now what do you know about the angle? The displacement vector, this is the displacement vector, and this is the force vector, net force vector. All right, okay, net force vector is to the east, displacement vector is to the east. So how much is the net force? 25 newton. How much is the displacement? Of course, 2 meters. And the two vectors are 0 degree. Okay, so 50 0 degree is 1, so 50 joule. So the answer to the question is only 50 joule. Hey everybody, in this video tutorial, I'm going to go over. Hello everybody, in this tutorial I'm going to I'm sorry, I have a 100 kilogram man sliding on an inclined plane with 30 degree angle, right? What I ask you to find, well, let's say this is also, I don't know, 30 meter tall, right? What I ask you to find is the displacement of the man who rolls from A to B, right? So this path, the size of this red line, Okay, so this is this is not a physics problem. This is a geometry problem. So you have to use so car to one. So this is problem two. So instead of so sine 30 is equal to opposite over hypotenuse. So the red line is the hypotenuse, which is of course let's call it d for displacement. So displacement is equal to 30 over I don't know sine 30 sine 30. Okay, which is 60, but you don't have to do it this way. You can, this is 30 60 90 triangle. So what do you know about that? Its smallest side is x, and then the second smallest one is x root 3, and the opposite to 90 degree is 2x, right? So I gave you this one. This one is 30. If x is 30, 2x is 2 times 30 is 60, right? Okay, so this is, I think you can do various way, but on Wednesday when you take this test, I will probably going to ask you a physics question, right? I'm going to ask you how much work done by gravity. So what do you want to do? You have to find how much work done by gravity. Uh, so then W is equal to F D, right? F net, okay? F net D cosine theta. Now, what is the F net over here? Let's find that out. You have the gravity. What component of the gravity works? Of course, the parallel component. So mg, all right, sine 30. So m is 100, 9.8 sine 30. So that gives you, I don't know, let's call this 110. And sine 30 is half. So 100 times 10 times half. All right, so this is 5. All right, so 500, right? Okay, good. So work is 500, and this is the displacement. We found that 60. And the cosine theta, this is FG parallel, and this is D. All right, so the angle between these two vectors is cosine 0 degree, right? So W, work done by gravity, is 5 times 6 is 30. 1, 2, 3. So it's 30,000 joules. Okay, as simple as that. This is what I'm going to ask you on Wednesday. I did not ask you this one on the T14. T15, I'm going to ask you this one. All right, let's go to problem number 3. Problem number 3, we have a 30 kilogram object, right? 30 kilogram object, 30 kilogram grenade, and you throw it up. You just throw it up like this. When you throw it up, it moves to the north with a velocity, let's say 50 meters per second. What we want to know is the momentum. So the momentum would be mv, right? That's the equation for the momentum. So the momentum would be mv. So momentum is 30 times 50, which is 1500 kilogram meter per second, or 1500 Newton a second. All right. So this is the momentum before. Now what we're going to do is try to find, try to make the problem interesting. Let's say this grenade hits something and broke in 2 pieces. Broken how many pieces? Broken 2 pieces. Is it working? Working. Okay, good. So the first piece is this one. First piece moves 10 meter per second, and that is 15 kilogram, right? 15 kilogram. And second piece is this one. Moves to northwest, right? Move to northwest, and that is also 15 kilogram. 15 kilogram. What I want to know is the angle of the resultant. Okay, good. So the first thing first, and that is to find out the x component of this one and y component of this one, and how can we find it? Because x and y is unknown. So x and y, right? So momentum before at x is equal to momentum after at x. Momentum before at x is 0. This is the momentum at the what direction? At the y direction. So momentum before at the x is 0. Momentum after at x is m1 v1x plus m2 v2x. I have a m1 v1x. However, I don't have v2x, so this is v2x. Good. Now, what is this? A 15 times 10, positive 10, because this is moved to the east. Plus, I just want to make sure you understand this is east, this is west, this is north, this is south. Good. M2 is 15 V2x. So you see that negative 150 divided by 15, which is negative 10. V2x is negative 10 meter per second. So we know V2x, and that is negative 10 meter per second. Of course, this value agrees with the geometry, which is the direction. Now it's time to find momentum before the y is equal to momentum after the y, of course. Momentum before the y is, of course, 1500. So 1500 is equal to momentum after m1 v1y plus m2 v2y. Okay, this is not a bad time to draw v2y. So this is a v2y. Good. Now you have 1500 is equal to 15. This is x. The velocity is the x direction. So 0 plus 15 times. You have to find this out. So v2y is equal to 1500 divided by 15, which is so 1500 divided by 15. Okay, so now v2y is equal to, this is 100, right? Okay, good. So now we know this one is 100. Excellent. Now we have to find the angle, right? So what is the angle? Angle is, by definition, inverse tangent 100 y over x, of course, y over x. So tangent y is positive 100, positive 100, negative 10, negative 10, negative 84. Please do not jump to conclusion, because this is not an answer. This is not an answer. That's what you probably think, but this is not an answer. Okay, this is your x and y coordinate, and now you put the vectors that you want to find from the beginning, this vector. So let's put this vector over here. If I put this vector, it doesn't look like 84 degree. And where do you measure the angle? You measure the angle from x-axis counterclockwise. This is what we are trying to find. This is not 84. So what is negative 84? This is negative 84. So this must be then 96. All right. So the resultant vector, this is the resultant vector. The angle of the resultant vector is 96 degrees. So yeah, this was problem number 3. Now we're going to do problem number 4. I'm going to try to understand a 2 kilogram ball, right, falls 1.2 second, and we want to try to find is kinetic energy right before it collide with the ground. So impact kinetic energy. So let's first find the distance. What would be the height? Okay, so let's say d is equal to half or bat plus half at squared. This is 0 because you're dropping it. Velocity, when you drop something, initial velocity is 0. So half 9.8 and 1.2 square, and this is 4.9. So d is 4.9 times 1.2 squared, and that is approximately 7, which is enough for us. Now ke on the bottom is equal to pe on the top. Pe on the top, right? Of course. So then ke on the bottom is mgh. M is 2, right? G is 9.8. I'll just say 10. And H is, of course, 7. So now 140 joule. And that is the kinetic energy at the bottom. So we use the conservation of energy, but you can totally use Newtonian mechanics and get the same answer. Okay? All right. Problem number 5. Problem number 5, this is the vector problem. I give you one vector. I give you this vector is, let's say, 12 Newton. And I give you another vector. Let's say this vector is 13 Newton, and I gave you the resultant. A resultant vector is, of course, 14.36 Newton. I ask you to find the angle between these two vectors. Of course, the way to go is using the parallelogram. So r square is equal to a square plus b square plus 2ab cosine angle. So r square is 14.36 square. 14.36 square is equal to a square is 12 square plus b square is 13 square plus 2 12 13 cosine angle. So this must be 206 and this is 144. This is 169 and this is 312 cosine theta. So this must be negative 107 is equal to 3102 cosine theta, and c must be theta must be cosine inverse, right? Cosine inverse 312 divided by negative 107, and that gives you 110 degree. So then this must be 110 degree. So law of parallelogram, but you can do it other ways, but law of parallelogram would be time saving, and during the test you want to save time, so it's probably going to take 1 minute. That takes us problem number 6. Have x and y axis. I have vector a, which is 12 newton, vector b, which is also 12 newton. Vector a is 30 degree above the x-axis. What we want to find is the resultant angle, right? To find the resultant angle, we have to create the parallelogram, but the here is this is a special type of parallelogram which we call rhombus. How do you know? Because the both sides are the same, 12 newton. That makes our life much easy. That means if you draw a parallelogram, the parallelogram, the resultant cut the parallelogram in half. What does that mean? That means you have 30 plus, this is of course 60 divided by 2. What does that mean? This is 30 plus 30, which is 60 degree. How the resultant gonna look like? Let's draw the parallelogram. So this is the parallelogram, right? And this is the resultant, right? So the resultant cut the parallelogram in half. So if this one is if 30, this one must be 60, then this one must be 30, right? So then this one must be 30 plus 30, 60, and that's what you see over here. That doesn't mean every time I'm going to give you numbers, but if I do give you numbers, you save your time. Number 7, all right? So problem number 7, you have let me give you first x and y axis, why not? And then I have a vector a, which is a vector a, which is 7 newton. A is 7 newton. Vector b also, let's say 7 newton. Okay, no, not like that. Let's say I have a vector b which is like that, vector b which is like that, and b is 7 newton. And I did not give you the angle between them, but I draw it in let's say I draw it to the scale. So this is how you're going to find the angle, right? You're going to use the protractor. So the protractor going to give this one is 53 degree. So the angle between A and B is 53 degree, right? So I want you to find the resultant. How you going to find the resultant? Of course, r square, law of parallelogram, is equal to a square plus b square plus 2ab cosine c. So r square is a square is 7 square plus, of course, 7 square plus 2 times 7 cosine, of course, 53 degree. So r square is equal to 49 plus 49 and 49 plus 49, right? Plus resultant is 12.5 and newton, of course. In this case, resultant represent the force. Okay, 4 kilogram car moves 2 meter per second, collide with well, let's draw the other car as a 5 kilogram car moves 4 meter per second to the east. So this is before collision. All right, let's give you the scenario after collision. What happened to the 4 kilogram car and what happened to the 5 kilogram car? 2 meter per second east. Okay, now we are trying to find the direction of this car, 4 kilogram car. Well, momentum before, which is this one, which is this one, momentum before, which is this one, is equal to momentum after, which is this one. All right, momentum is conserved, right? What did you tell you? The in the collision, all type of collision, elastic, inelastic, whatever, the momentum is conserved. However, kinetic energy not always conserved. But in this case, let's see, momentum before is equal to momentum after. So m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime. Okay, so what is m1? Of course, 4 times negative 2. Why? Because this is to the west. Plus m2, 5 times 4. Why is 4? Because it's to the east. m1 again, 4 kilogram. v1 we are trying to find, plus m2 is 5. v2 is 2. Why 2? Because it's to the east. So this is negative 8 plus 20 is equal to 4 v1 prime plus 10. All right, so here you have a 12 is equal to 4 v1 prime plus 10. So here you're going to have a 2 because you move it to the other side for v1 prime. So then v1 prime is equal to 2 over 4. So then this is 2, so half, which is 0.5, right? So the answer to the question is this is 0.5 to the east. So this one is moving because the answer is positive. So this must be moving to the east with how much? 0.5 meter per second. Problem number 9, 23.35. I gave you the resultant 23.35 Newton, right? This is probably the easiest problem in the test. Why is that? Because I ask you, this is resultant and find is two perpendicular component. I say two perpendicular. I didn't say one would be like this, other would be like that. This is not perpendicular, right? No, the perpendicular would be like one would be like this and other one would be like this, right? Okay, so these two are perpendicular, so this must be 90 degree. So you are forced to use Pythagorean theorem, right? What does that mean? C squared is equal to a square plus b squared. What is c? C is this one, right? So 16 and 17 will do the job because 23.35 square is equal to 16 square plus 17 square. Or you can do it other way. You can say c is equal to square root of 16 square plus 17 square, and that will do the job. Okay, so this is very easy, and this is going to give you 23.35, right? And 16 and 17, what would be the other thing gonna give you 23? Nothing. That's it. Only one pair in the universe that gives you 23.35, and that is 16 and 17. No other pair will give you the same resultant. Okay, that takes us problem number 10. So what happened? Problem number 10 is few step, actually 3 step, right? First find the reaction time, um, and then you're gonna find how far your car move before it come to full stop, because you have to hit the brake, because when you're driving, you saw someone crossing the road, you try to save the person. Will you be able to save? Well, depend on your reaction time. Let's first find the reaction time. D is equal to vit plus half plus half at square, right? Now this is 0, of course, and we are trying to find the time, right? So then the time t squared is equal to 2d over g, right? This is g because your reaction time, you drop it. So t squared is, of course, you have 2 times 0.7 over 9.8, and this gonna gives you 0.37, right, a second, of course. Now the next thing you're going to do, you are in the car, right, and you saw someone crossing the road. Okay, your immediate what do you do? You immediately brake, hit the brake, right? So the velocity over here would be let's see, the velocity over here would be 30 square. So the velocity over here is 30 meter per second, and velocity over here also 30 meter per second. Hopefully the velocity over here, hopefully the I don't know, the car may stop before the man, or at the man, or after the man. Okay, but when the car stops, the velocity is zero, right? If the car velocity is zero before it hit the man, then man safe. If the car velocity is zero, why it is zero? Because he hit the brake over here. At right here, he hit the brake. He slammed the brake. Okay, so velocity is zero over here. So what are we trying to do? This is a constant velocity from location A to B is constant velocity. From B to C is not constant velocity because it's negative 4.5, right? Meter per second square. Okay, good. This, because of this acceleration, the car velocity from 30 meter per second to location C, the car velocity is zero. Hopefully C is before he hit the driver hit man. Okay, so let's first find at the distance here. Distance is VT, right? Okay, so the distance is 30 times 0.37. That's about 11 meters. Okay, now here velocity is zero over here, so Vf square is equal to velocity is 30 over here, Vi square plus 2AD. So this is zero, and this is 30 square plus 2 negative 4.5 D. So D is 100, right? So the driver moves, right? Driver moves meters from location A where he saw the man. The man is only 60 meters away from the driver, so the man didn't survive. But the moral story is the driver tried to save the man. Okay, so that was problem 10. We are half of the way now. Remaining 10 we're gonna solve now. When I have a problem like I have a vectors like this, and this vector is vector A, let's say 9 Newton, and this say this is vector B. Vector B is 10 Newton, and the vector A is well, let's say vector A is 300. This is 300. This is 90 degree, of course, and this is, let's say this is 310 degree. This one is 300. 310 degree means, I don't know, minus 50 degree. Okay, so I want you to find the resultant. Okay, so let's see. Resultant would be r squared is equal to a squared plus b squared plus 2ab cosine c. R squared, a squared is of course 10 squared, b squared is of course 9 squared plus 2, 10, 9, cosine 140. How it is 140? So this is 310, this one is 310, right? This is 310, so this must be 50. This is 90. 90 plus 50 is 140. Okay, so then R is I don't know, R is 6.6 Newton. Okay, this is problem number 11. Now let's do problem 12. 12 is very easy. Problem 12, we have one vector is x Newton, right? And other vector is let's say 5 Newton, and the resultant vector is 10 Newton, right? Okay, if the resultant vector is 10 Newton, an angle between, and also given angle between two vectors is 0 degree, right? Then this must be 5. This must be 5. Okay, otherwise, if this is 5, this is 5, and their angle is 0 degree, then resultant must be 10. Otherwise, you can never get 10. 1 degree, you're not going to get 10. 1 degree, you're going to get less than 10, right? 180 degree, you're going to get 0, right? Exactly 0 degree angle. If the angle between these two vectors is 0 degree, then this one plus this one must be 10. So then if this one is 5, this one must be 5. Would be you have a mailman move vector A 17 kilometer to the north, and then the mailman make 48 degree southeast, right, to move 28, that vector B kilometer, right. What we want to find is the mailman resultant vector. So how can we do that? All right, so a few things. If this is 48, all right, if this is 48, this is, let's say this is 50. If this is 50, this should be 40, right. Now this should be 42. If this is 42, and then let me take the calculator. Let's draw the parallelogram. If I draw the parallelogram, I have to draw this vector over here, this vector, and then the vector, this vector is right. It's okay. So this is the parallelogram. So what is this angle? All right, 180 minus 42. 180 minus 42, and that would be 138. 38. Okay, all right, that's it. That's all we needed to do. Now let's find the resultant. So you have r squared is equal to a squared plus b squared plus 2ab cosine and c. Now this you're gonna have to plug in this 138. So r squared is equal to a squared 17 squared plus b squared, which is 28 squared plus 2 times 17 times 28 cosine, of course, 138. All right, and I'm gonna put those things directly to the calculator. So 17 squared plus 28 squared, all right, plus 2 times 17 times 28 times cosine 138. Now we're gonna get to see the answer. So what do you see? I don't see it. 19.11, 19.12. Have a 10 kilogram box. You pull it, applying some 45 Newton at a 30-degree angle, and mu k is 0.3, right? And and the box is moving 3 meter, right, from location A to location B is just 3 meter. Want to find work done by friction. So few things we have to know. We have to draw a free body diagram. We already uh, uh, we can know that by using 45 cosine 30. This is Fy 45 sine 30. This is 98 Newton. This is, of course, F is Fn. We have to find Fn. So what is Fn? Fn would be, all right, let's see. So this is 22.5. This is 22.5 Newton, and this is 38.97 Newton, right? So this must be 75.5 Newton. So then FF should be mu K Fn. So mu K is 0.3 and Fn is 75.5. So this must be 22.65 Newton, right? So work done by friction would be what? Fd cosine theta. Now FFD, right? And now which is the direction of FF? This is the direction of FF. This is the direction of the D. So then the angle would be 180 degree, of course. FF is 22.65. And D is, of course, it moves only 3 meters. So work done by friction has to be a negative 68 joule, right? Okay, so that was question number 14. You have a 12 kilogram object, right? You have a 12 kilogram object. So now you have FA is not given, acceleration is given, which is, let's say, 3 meter per second squared. FF is given, which is 10 Newton. I want you to find out the work done by net force. All right, so now first thing first, let's oh, by the way, the object moves, let's say how much. The object moves 2 meters, right? From location A to location B, object moves how much? Let's say 2 meters. Okay, now, all right, so the first and foremost, we're gonna have to find FA. So F is equal to MA. What does that mean? All the force acting at the x direction. I have FA minus FF is equal to M is of course 12. A is of course given by 3. So FA minus, of course, force of friction is 10. So then FA is 46, right? Okay, good. However, 46 is not net force. This is 46. So the net force is 46 minus 10. Net force is 36. So work net is equal to F d cosine theta. What kind of F? Well, net. So the net would be F net is equal to all the F, right? So F net is equal to all the F is FA minus FF. FA is 46 minus 10, so 36. So net 36. Work net times D is 2 cosine, of course. Net force is which direction? Net force is this direction, and the D is also this direction, so this must be 0 degree. So net is 72 joule, capital J. All right, standing jump, right? So what do you want to do with this standing jump? Let's see. Okay, so when you do this standing jump, how much do you jump? Say, let's say 0.25 meter. And how much do you crouch? Let's say you crouch 0.31 meter, right? So I want to find the acceleration. So work is equal to what? Work, right? Work is equal to work, right? So then work is equal to what? mgh, right? This is mgh or potential energy on the top, or you can write potential energy on the top is equal to work. What is it? Fd cosine theta. Okay, potential energy on the top is, of course, you have mgh. So mgh is equal to F is equal to ma d cosine 0 degree. So cosine 0 degree is just 1. Cancel. Acceleration is gh. G is 9.8. All right. D is how much did he crouch? 0.31. And the height, how much did he stay in the air? 0.25. Okay, and that is 7.9 or approximately 7.9 or 8 meter per second square. Okay, now the man is 2000 kilograms. So I have, this is the earth and this is the man, and man is 2000 kilogram. All right, you can find this type of man at McDonald's. So the man is 2000 kilogram. Now we want to know the net force, the acceleration of the earth. So then Fg is mg, right? Okay, so 2000 times 9.8, and that would be 19600 Newton. How do you read this? You're gonna say Earth is pulling the man, 2000 kilogram man, with this much force, okay, 19,600 Newton, and the man is pulling the Earth with 19,600 Newton. This is called Newton's third law, okay? Equal in magnitude, opposite in direction. Now let's see the other one, F push. F push is mg plus a. So m is 2000, g is 9.8, acceleration is 7.9. Okay, so this is 35400 Newton. So 35400 Newton, right? 35400 Newton. And then that must be, this is F push. This is also by Newton's third law. F push is also 35400 Newton. 35400 Newton. Okay, good. Now we want to know the acceleration of Earth. So we have to take this vector, which is upward, and we have to take this vector, which is downward. Okay, so this vector minus this vector divide by the mass of the Earth. That's it. That's all you need to do. So acceleration is net force divided by mass of the Earth. Acceleration is net force is, of course, 19600,35400 divided by 6 times 10 raised to negative 24, right? This is the mass of the Earth. 2.6 times 10 raised to negative 21 meter per second square. Marble rolls 5,000 meters, right? 5,000 meter, maybe 8,000 meter. 1, 2, 3, 8,000 meter for 5 hours from location A to B before it falls 80 meter above the ground, and we are trying to find impact vertical velocity. You can completely ignore that, right? Because over here, right here at location B, velocity Vx and Vy is 0. Okay, so let's find the time. D is equal to Vit plus half at square, and you see that Vy is 0 means dy Vy ay. This is 0. So distance is 40 is equal to half 9.8 t squared. So 40 is equal to 4.9 t squared. So t is equal to 2.86, right? And how that can help you? Well, velocity final is equal to velocity initial plus at. Vi is 0 because y direction velocity is 0, right? So v final y, that means the velocity right here is equal to ay 9.8, and that is 2.86, and that is 28, right? Velocity is 28 because this is 10 times 3 is 30, so this is 28 meter per second. A box accelerates on 60-degree incline, right? What do we know? Acceleration is well, let's how can we solve that? Let's say acceleration is g sine theta. Okay, g sine theta would be when friction is when there is no friction. Since there is a friction, minus, you want to write mu k f mu k mg cosine 30, cosine whatever, cosine 60. So 9.8 sine 60 minus mu k, which is 0.4, m is okay, m all right, I think there is no m over there. Cancel because yeah, cancel. Let's see, let's show you where this equation come from. Okay, let's see. You have f equal to ma. All right, what type of f? Fg. What type of fg? Parallel. So what would that be? Well, that would be mg sine okay. All right, so then you have to write the friction. The friction would be mg. All right, oh, okay, so friction would be mu fn is equal to ma. So mg sine theta minus mu fn is mg cosine theta is equal to ma. M cancel. So g sine theta minus mu g cosine theta is equal to a. All right, so there is no actually m over here, so that was a mistake. So then acceleration is 9.8 sine 60 minus mu is 0.4 9.8 cosine 60, and that would be 6.54. Acceleration is 6.54 meter per second squared. All right, so that was problem 18. Now we're going to do two more, 19 and 20. That's yeah, I have a string and I have a mass, and the string is 0.7, which is the radius, and I want you to find the acceleration. So velocity is distance over time, so 2 pi r over t. What is t? T is the period, and let's say it takes all right, okay, so this is our velocity. So acceleration is let's write it down. Acceleration is v squared over r. So acceleration is v squared over v squared times 1 over r. Acceleration is v is 2 pi r over t squared 1 over r. So acceleration is 4 pi squared r squared over t squared 1 over r. Okay, so acceleration is 4 pi squared r, and then this is the period square t squared. Okay, so 4 times pi, which is pi squared, which is r 0.7, and t over 1, and t is as you know that period is time over cycle. So 1 second 6 cycle, so then you want to write 1 over 6. All right, okay, so how are you going to do that? So 4 pi squared 0.7 over 1 times then 1 over 6, right? So 6 is square, right? Because this is t squared. So 6 is squared. So that gives you how much? 94 meter per second squared. To find the acceleration. Okay, good. Now I have something like that, and well, dt graph is given, so I'm going to convert it to vt graph, right? From 1 to 2 seconds, the object velocity is 2 meter per second. From 2 to 3 seconds, object velocity is 0. From 3 to 4, okay, so this is 2, 3, 4, 5, that's it. Okay, and the displacement between 3 to 4 seconds is also given, is right here. I'm going to show you the graph. This is the graph, right? Okay, so the displacement is 8 minus 4, this is 4. Okay, so this is 4, and this is also 4. Okay, good. Now you know our goal is to find the slope of this line. That's it, that's the goal. Slope of this line. What will be the slope of this line? Okay, fast and fast, you're gonna have to find the here, this one. If we know that this point and this point, we can find the slope. We kind of know this one. This one is 3. We know this one 5. Okay, so we're gonna have to know this one. We're gonna have to know this one. Okay, good. How can I know this one? Okay, so the area is half bh. What is area? Displacement. What is b? Time. What is h? Velocity. D is 4 is equal to half. Time is 4 minus 3, 1. Velocity. So velocity is 8. So here is 8. So this is 8. This is negative 8. So this is negative 8. So slope is, as you know, slope is y2, which is negative 8, minus y1, which is 8. x2, which is 5, minus x1, which is 3. So slope is minus 60 over 2. So what is the name of the slope? Acceleration. Acceleration is minus 8. So this red line, the acceleration of this is is minus 8 meter per second square. All right, good. Now what are we gonna do? Oh, that's it. That's all I asked you to do. What is the acceleration when the time is 4.8 seconds? When time is, what is the acceleration when time is 4 seconds? Same. Acceleration when time is 3.5 seconds, same. Okay, acceleration is constant. Between 3 to 5 seconds, acceleration is constant. Okay, now we're going to do the last problem, and that is the extra credit. Extra credit. I gave you a DT graph, and I gave you object like this, and the maximum height I gave you 10 meter, right? So this is this is a DT graph, and the maximum height I gave you 10 meter, and the time it takes the object to reach maximum velocity. We're gonna convert it to VT graph. I ask you, what would be the velocity at, let's see, what did I ask you? I ask you, find the velocity at 1.9 seconds. So what is the velocity of the object right here? Velocity is what? Okay. So let's find it. This is 0. So this is 0. Maximum velocity. Okay. All right. Here we know it. How much? 10. This point we know it. What is it? 0, because the time is 0. Comma, we're gonna find it. Here we know it. The time is 1. So 1, velocity is 0. Here we kind of know it. 2 comma, we're gonna find it. So we don't need to find 3 point. We can find 2 points and take it from there. All right, what is the velocity over here? So half d is equal to half bh, or area. Area we call displacement is equal to half b equal to time, a is called velocity. Displacement is 10 is equal to half the time is 1 v. So this is 20. Velocity is 20 over here. So this is 20. So this must be negative 20. All right. So then we have to find the acceleration. So what is the acceleration? Acceleration is v final minus v initial, t final minus t initial. So acceleration is negative 20. Now acceleration is negative 20. Now we can find velocity final is equal to velocity initial plus at. Velocity initial is of course 20 minus 21.9. Okay, so VF is 20 negative 18. Okay, so